Hello, everyone. Today we are going to talk about scatterplots. And the definition of a scatterplot, you'll see on the screen here, is a graph that shows the relationship between two data sets. The two sets of data are graphed as ordered pairs in a coordinate plane. So, a couple things there to unpack. First of all, remember an ordered pair is going to be your x comma y. So those are going to be your numbers there. It is a graph that shows the relationship between two data sets. The two sets is whatever you're putting on the x is one set of your data, and whatever you're putting on your y-axis is the other set of data. And then remember, our coordinate plane is going to be, we've got our four coordinates and our four quadrants, quadrant 1, quadrant 2, quadrant 3, and quadrant 4. For the purpose of most scatter plots, we're going to focus right here in quadrant 1. So it's kind of like zooming in into quadrant 1. So these three examples I showed you right here are actually just examples of what scatter plots could look like. It's a coordinate 1 graph with lots of dots all over the place. So let's learn a few things about scatter plots. First of all, you need to be able to interpret or read a scatter plot. So let's look at this example here with pre-made scatter plots. First of all, it says the scatter plot on the left, which is this one here, shows the amounts of fat in grams and the numbers of calories in 12 restaurant sandwiches. So notice the two sets of data they're comparing is grams of fat and calories. So those are our two sets of data. So part A says how many calories are in the sandwich that contains 17 grams of fat. So it's just like looking at your coordinate pairs where you're saying that 17 is going to be where you're looking at for the fat, which would take you about right here on the graph. And then you come over to the Y and you'd say, okay, that's about 400. So you've done this before just without scatter plots. You've read a lot of data in your math career. Part B says how many grams of fat are in the sandwich that has 600 calories. So on this one, you actually start on your Y at 600, go across, and then go down until you get to your X, and you find out that it has 30 grams of fat. So the answer there is 30. So that's just interpreting and reading a scatter plot. Okay, so the next thing that's really important about scatter plots is what kind of association there is between sets of data. So there are four types here. There is a positive linear relationship, which you notice happens where as your x increases, your y increases. They both go up, okay? Then there's a negative linear relationship. Notice I am saying linear because it looks like a line. But for this one, as your x increases, so as our x goes increasing, our y is actually decreasing. We also have a non-linear where it doesn't form a line. It goes more of a curve, but they're still kind of close together. And then if your dots and if your plot points are just kind of scattered everywhere and they don't make any sense at all, then it would have no relationship at all. So when we look at these, couple things to point out. Again, I already mentioned linear and nonlinear, but strong versus weak, the closer together the dots are, the stronger the association is. The farther apart they are, the weaker it is. So let's look at an example. On here, it says, describe the relationship between the data. Identify any outliers, gaps, or clusters. So the first one here is going to compare the size of a TV and the price. So if you notice, if I look here, it looks like it's kind of going on that upward trend, okay? Not perfect or anything, but it does say that the points appear to lie close to the line. And as X increases, Y increases. Kind of makes sense. The bigger TV you want, the more money it's going to cost. So when I look at that, though, we do have a few things here to point out. If you have a data point that it just doesn't seem to go along with the rest, that's called an outlier, okay? It lies farther away from the rest. If you have some data points that are closely grouped together, those are called clusters. So we've got some clusters in this. We've got some outliers in this as well. You might also have a gap, and a gap is where when I drew that line, we just had kind of no dots there, and I drew over it, but we almost had this space right here that formed a gap if I erased all of that. So if I look at this, I would definitely say there is a relationship between the size of a TV and the price. Look at B, the age of somebody and the number of pets owned. So if you look at this, you should see right away there's no line formed. It's not curved. It's not even close to a line. There is no pattern, so that there is no relationship. So, notice, a 10-year-old has 3 pets right here. And then I've got, a 30-year-old with none. And then I've got a 50-year-old with 2. So there's no relationship at all. So that's what you're going to be looking at is, are there relationships? Is it going to be linear? Is it nonlinear? Is it strong? Is it weak? It's really looking for what kind of relationship 2 data sets have.